All right, guys. So in this video, we're going to talk about visual presentation of data. And we're going to start with presentation of qualitative data, which consists of ordinal um, and categorical data. So we're going to start off with this example. So I asked my students in the previous semester, what is your major? And below I have their um, recorded answers. All right, so let's organize and present this information. I'm gonna switch to my document camera now. So here we are. And what I'm gonna do, I'm gonna list each major as I come across. So for example, the first one is business. So I'm gonna write this down and put a tally uh, once I come across this major. So as you could see, I have more of the business majors, but I'm gonna actually go down the list and just put a tally mark each time I come across this major. Also, I'm gonna combine the business management, what else? There's some business admin as business. Okay. And so so far I have only one. Then the next one is gonna be a biology. I got one of those. Then I also have undecided major, one of those. Then well, I have kinesiology. Okay, surprisingly, we got a few. And then the next one is business administration. So I'm just gonna put the next one more tally mark there. And I'm gonna just go down the list and continue this. I'm gonna pause for this process. And you know what I'm gonna do also? I'm gonna cross out the ones that I already accounted for so that I don't lose my spot. So I'm gonna continue doing that. All right, so I'm done with the process, and here's what I got, quite a long list of majors, and then I have tallies. So now I can count how many occurrences of each do I have. We're gonna call this frequencies in this class. So those are frequencies. So for business, I have 15 and 318. For biology, there is 4. For undecided, 3 were undecided. Kinesiology, I have 6. Computer science, 8. Finance, 3. Nutrition, 1. Education, we have 7. Justice, criminal justice, 1. Health, 2. Psychology, 1. And language arts, 1. So we got our table. It's called a frequency table. So this is the organizing of our data. Now we can what else can we do that? How can we visualize this data? So what we can do, we can construct a frequency, relative frequency distribution. Okay, so before we visualize it, we have to talk about relative frequency. So when we add all of the frequencies up, we're gonna get a total. Our total number should equal to our sample size. So what is our sample size here? I added up all the numbers and I got a total frequency of 55. So my sample size here is 55. Um, so, but let's talk about relative frequency. So relative frequency is basically a percentage of each group. in a total. So for the relative frequency, for business, I'm gonna have 18 divided by 55, which is gonna give me, I'm gonna round here, 0.33, which is actually 33%. So your relative frequency is gonna be either a fraction, a decimal, or a percentage. All right, so I'm gonna actually go ahead and figure out all the rest of the frequencies, relative frequencies here. So here I have this process completed. Now I would like to switch it over to a spreadsheet. So here's this same information in a spreadsheet, only I kept my decimals more accurate. So I could, I wanted to make a point that when you add up all of the fractions, you're gonna get approximately a 1. Right? And if I wrote my percentages here, so 0.327273 would translate into 32.73% and so forth, and I would add all the percentages up, I would end up with 100% here. So that's the expectation. And if everything is done correctly, that's what should happen. So now when we have our data organized in a frequency distribution, we can present it visually by constructing a bar graph with it. So what we're going to do, we're going to create our graph, and on the x-axis, we're going to have our categories. So we're going to have our business, um, and then biology, and then undecided was next. All right, and then so that's on the x-axis, and on the y, so majors are going to be here. And so forth. We're going to continue. And on the y-axis, we're going to put counts, so frequencies. So my highest frequency in the table was 18. So I'm going to make sure that I have 18, I can fit 18 equal parts here. So let's start. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18. Okay, 20. Actually, I should just put 20. All right. So my first bar is corresponds to a frequency of 18. That's what we had for business major. So it's gonna go up to 18. All right. My next bar for biology only had 4 counts. So my bar for biology is going to only go up to 4. Okay, so undecided, I had only 3 for undecided. So this bar is only going to go up to the height of 3. So, and if I'm going to continue doing that for all of the majors in my table and all of the frequencies in my table, I'm going to have the following graph. So this is my graph that I had generated by StuckCrunch, and I have tutorials where I show how to generate those graphs in StuckCrunch. But this is what our frequency distribution bar graph looks like. Now, when you have ordinal data, and remember that ordinal data is different from categorical data in that it could be put in order, right? In certain logical order, like, for example, grades, A, B, C, D, F. So we want to, with ordinal data, we want to preserve that order. So when we're doing bar graph for, let's say, grades, then we would list them in a certain order, either from best to worst grade or from the worst to best grade. It's up to you, but it's going to be in order. So when you data is organized in order, it's now called a Pareto chart instead of the bar graph. But the idea is exactly the same. The only difference between bar graph and Pareto chart is order. Okay, so for majors, there is no order for majors, but there is order for grades. So when you create a bar chart for to represent grades, that's gonna be called a Pareto chart. So what else can we do? Well, we can create, instead of putting counts on the y-axis or counts of frequencies, we can put relative frequencies on the y-axis instead. So let's see what that would look like. So here, again, I have my majors on the x-axis, and then uh, the percentages on the Y. Now, for the first category, business, we had about 33%. So my bar would go up to about 33 for business. Okay, for biology, I had 7%, so it's gonna go up to 7. For undecided, I had a 5%, so it's gonna go only halfway, between 0 and 10, and so forth. We're gonna continue doing this for the rest of our major. And here's a spoiler. When you're done plotting it, it's gonna look exactly like your frequency bar chart. The only difference is that your y-axis will be labeled differently. But other than that, the bar heights and everything else is gonna look exactly the same. So what else can we do with this data? How else can we represent it? Another common chart that you're going to see is called a pie chart. And so it's basically, as you guessed from the name, it's a circle. And each slice of the circle will cover the area that, that corresponds to the percentage, right, of that major. So in this case, our business is going to cover 33% of the area of the circle, which is exactly a third, actually. So this part will represent business majors, right? And then for biology, we have only 7%. So it's a way smaller piece. So biology and so forth. We're gonna actually go ahead and do this for all of the majors, and let's see what the final result looks like. So here again, I asked StockCrunch to create this graph for me, and it did. So this is what it looks like. And so here we have our majors listed, we have counts, and we have percentages as well. So this is, we don't have to actually create those graphs by hand. We just have to understand what they represent and be able to read them. Now, again, the quantitative data could be presented in the same way as qualitative. But as we progress, like from the most simplest types of data to more complex types of data, the ways we can represent the data grows. Okay, so for basically this is it for um, qualitative data representation, so bar charts, frequency tables, tallies, and pie charts, but there is more that we can do for quantitative data.